The lesson on combined circuits continues with a look at what happens when you have many resistors in one circuit. The resistor itself, as you can see here, is simply a device that is made from a carbon mixture or other material so that it has a well-controlled resistance in a small package. We don't want a metal wire because the resistance of a metal wire changes with temperature. Let's look at resistors in series first. Here's a 10 ohm resistor and another. Resistors have the function of reducing current. The current has to go through both resistors, so the current is reduced by both resistors. So, the total resistance, RT, is simply the sum of the two resistances. In parallel, it is more complicated. The current can go in different directions, so the charge splits. I like to think of it as being similar to cross-sectional area. If we have a resistor made of that carbon powder and put it in parallel with another resistor made of carbon powder, what we are really doing is increasing the cross-sectional area of the carbon powder. Not the length, just the cross-sectional area. We saw before that increasing the area decreases the resistance, because resistance is proportional to 1 over the area. So, putting resistors in parallel will always reduce the resistance. This means if I have a 10 ohm resistor and a 1000 ohm resistor, the total resistance will be less than 10 ohms, less than the smaller amount. Here's the formula. 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3, etc., etc. It's actually fairly simple to use, as I'll show. Let's start with two 10 ohm resistors. 1 over RT equals 1 over 10 plus 1 over 10, which equals 2 over 10. So RT over 1 equals 10 over 2. Just flip it over. Notice that I like to flip the equation here. It's easier than calculating everything and then trying to get the reciprocal. Plus you're less likely to forget doing it this way. Anyway, that means RT equals 5 ohms. Never leave your answer as a fraction in physics. We want to know how many significant figures there are. By the way, did you see that taking two identical resistors meant we simply halved the resistance? That's easy. But what if they are different? Let's go with 10 ohms and 20 ohms in parallel. So 1 over RT equals 1 over 10 plus 1 over 20. Let's double up here to 2 over 20 because that lets us add the fractions together, giving 1 over RT equals 3 over 20. Flip it, RT equals 20 over 3, which equals 6.66666667. And we're going to round it now to 3 significant figures as 6.67 ohms. Now, let's look at some resistor setups. The 3 circuits here look different, but if you look carefully, you'll see they are actually all the same. If we go from one terminal to another, we can only go through one of the 3 resistors. The reason to show this is simply to remind you to be careful with circuits and doubly careful in tests. Don't just glance quickly at a circuit and assume you know what it does because you've seen something similar before. Take your time, analyze it, and use the rules we have covered to work out what is going on. Different setups can give the same behavior. Let's say A, B, and C are all 30 ohms. What's the overall resistance? 1 over RT equals 1 over 30 plus 1 over 30 plus 1 over 30, that's 3 over 30. So RT equals 30 over 3, which is 10 ohms. Do this for any of those, you're going to get the same result. It's the same for all of them. And this also means that instead of buying 3 resistors, I could have just done this and saved myself some money. This is called an equivalent circuit, as it has the same behavior as what I replaced. To solve complex combined circuits, simply do it like this and break the problem down. Think of an equivalent circuit and then think of another equivalent circuit and break it down until you have a single resistor. Now here's another one. This one looks tricky to figure out, and I want to know the total resistance of this circuit. Pause the video and give it a try. Okay, so hopefully you paused it, hopefully you've got an idea. First step is always to combine the resistors in series. If you're stuck, now you've got that idea, give it another go. Combine the resistors in series first. I'm going to carry on, I'm going to sketch it. So this section becomes 12 ohms as it's in series, and here is the equivalent circuit. Now we have a parallel section to sort out, but luckily they are both 12 ohms, so I know the total resistance is going to be 6 ohms. But let's work it out anyway. And here is the new equivalent circuit. Lastly, resistors in series, so we sum them and get the total resistance equals 12 ohms. R1 plus R2 equals 6 plus 6 equals 12. And here for completeness is the equivalent circuit. So there's a complete overview of combined circuits and how to understand them using equivalent circuits. You should be able to now describe how current and potential difference is distributed throughout any kind of a circuit. So go back, make sure you understand it, write yourself some notes up, and then try some practice questions.